Hmm. Hello friends, in the previous session we were seeing the producer and consumer incorrect implementation and started with the correct implementation. In between electricity was gone, so I halted with that session and I started the new session with the same problem, same program. We will continue with the same program. We were at the synchronized void put here. If value set try wait and then catch interrupted exception. Now, after this else part, by default, this is the put. So this dot n is equal to n. Value static is equal to true, and put, I am printing put colon n. And after this, it will notify. Second class producer implements runnable. Add unimplemented methods like run, and this is creating queue object. Producer is passed queue object. This dot q is equal to q. This dot q is equal to q. Then new thread. This producer start. This producer start. In run, what I am doing is int I is equal to 0. While true, q dot put I plus plus. Class consumer implement runnable. Then add run method over here. After that, create a queue object over here also, queue. Then consumer is passed with the queue object. This dot q is equal to q, and new thread. This dot producer dot start. And run method int I is equal to 0. While true, q dot put I plus plus. q dot get. Then in class PC fixed, q is equal to new producer q and new consumer also q. And here also it will give you infinite output. But still, what is the advantage over here? Whenever put is completed with putting, then only get will get with the value. So first of all, put will put the value and then consumer will consume the value. Okay, because same q object is passed to both of the threads, producer and consumer. Okay, so when producer is called with q, what will happen? This thread will be started and its run method is entered. After that, while true, q dot put, unless and until it is true. And this q is synchronized over here, synchronize integer get, synchronize void put. Okay, so this value set will be checking. If not value setting is done, it has to wait. After value set is done, it will set it to true. Okay, after putting is completed, value set will be true, and when value set is true, then only it can read the value. Okay, first of all, put will put the value successfully, then only get will get the value. So these methods are synchronized over here, and whenever this q object is passed, first producer will start produce the value, consumer will consume the value. Okay, producer will produce and put the value from 0, 1, 2, 3, 4, 5, 6 like this, and consumer will get the same value. Okay, but what is the advantage over here using synchronized keyword is, unless and until put is not done with its job, get cannot be getted. Now, correct implementation demo, you can see over here. First of all, got, then put, got, put, got. Sequentially, they are coming. Okay. So there is a synchronization or mutual understanding between them. Now, we will move to the next code, that is deadlock. We will see project for this, separate project called deadlock. New project, deadlock demo. Now, I will create a package called package deadlock demo. a new class called deadlock with main method. Now we will create the same classes as in theory part. One class with foo method, another class with bar method. Class A, till they are synchronized, they create a deadlock situation. Why? Because one is having control on its own lock and trying to get the other threads monitor. But and same at the same time, another thread is waiting for this thread's monitor or lock. So at the same time, both are getting having control on their own locks, and both are trying to have the control of other thread's lock. So both are deadlocked at the same time. Now thread dot current thread dot get name. Thread entered a dot foo. Then try. In try, thread is sleeping. A is interrupted in between. Then after try catch, trying to call b dot last. Name thread is trying to call b dot last. And synchronize void last. In this program, if I would have written first of all B class, then only I would have the same error that B is unknown, A is unknown. Okay, because this is a deadlock example. Both are trying to access the each other's monitor or lock. Now then class B, I will create class this will have bar method. Synchronize void bar AA. String name thread dot current thread dot get name, that will main thread's name I am getting over here. Then name entered b dot bar. Then try catch thread dot sleep for 1 second. Catch interrupted exception be interrupted. Okay. So after try catch, trying to call a dot last. Who is trying? Name is trying. Name trying to call b dot a dot last because we are in b method. A dot last. Synchronized void last. We are defining over here inside b's last. Then main class runnable with run method. Now this will be the last because we have to define it first and then we have to call it. Okay, so call will be the last thing. First of all, a is equal to new a. We are creating object of class a. B then deadlock. In deadlock, default constructor, what we are going to do? Thread dot current thread dot set name main thread. Thread new thread this we see thread. So this why we are passing this because this is a thread class because it is implementing runnable interface and there is always there is main thread available, so we can directly get that main thread using thread dot current thread. So this is main thread, this is racing thread. So two threads we are having in our project and we are starting with the T. We are starting the T thread. Get lock on A in this thread. In deadlock default constructors. So A is trying to acquire lock on B is who method is present in A class. So B object, this B object is trying to acquire lock on A in this thread. Now in run method B dot bar. So bar method is present in which class? Bar class. B class. So A is trying to acquire lock on B. So get lock on B in other thread. Get lock on B in other thread. Back in other thread. And in this, we are just creating the object new deadlock. I will run this. Racing thread entered B dot bar. Okay. Then main thread entered A dot foo. So first of all, after creation of objects, we will go step by step. First of all, we created A is equal to new A. So this will go into A. In A, there is the foo method present. Okay. So in foo method, what we are doing, getting the current thread and entered A dot foo. So there are two threads available. Main thread is started first. So it entered A dot foo first. Okay. Then racing thread, second thread entered B dot bar. And main thread is trying to call B dot last. It is in foo and it is trying to call B's last method, and racing thread is trying to call A dot last method. Both are acquiring its own lock, and don't relinquishing control on its own lock, so that another thread can also not be completed, and also this same thread cannot be continued with its operation. So this way both are deadlocked. What is the solution to this? You have to first relinquish the control on your own lock, so that another thread can come in, another thread can complete its own operation, and then it can finish with the operation, and then you can acquire the control on their lock or monitor. So after this, we will see suspending, resuming, and stopping threads before Java 1.1 and after Java 1.1. For that, I will create project, new Java project, suspend, resume, demo 1.1 earlier. SR demo, package SR demo, previous. Now I create a class suspend resume over here. Suspend and resume. So now class new thread implements runnable. String name, it is the name of the thread. And thread T. Then new thread parameterized constructor, string name, string thread name. I am giving the different name for the parameter, so you can directly give name is equal to thread name. And then T is equal to new thread this comma name. System.out.println new thread. Its description is printed over here and it is started afterwards. Then entry point, in run method what we are going to do is try for int I is equal to 15, I greater than 0, I minus minus. Name plus colon plus I and thread dot slip 200 millisecond. Catch interrupted exception, thread name interrupted, name plus interrupted. Okay, so now afterwards exiting as usual, name is name exiting space. Okay. Then there is a class called suspend resume we have already created. In public static void main, we will create two objects, new thread. Object 1 is equal to new thread 1 and new thread object 2 is equal to new thread 2. Then try catch new thread. Class name is new thread, I'm sorry. Okay. Thread dot slip first 1000 millisecond, that is 1 second. Object 1 dot t dot suspend. Since we are going to see the example before Java 1. Before Java 2, all the versions before Java 2, so we are using here suspend and resume methods. Then suspending thread 1, again thread slip 1000 millisecond, and object dot t dot resume, object1 dot t dot resume. Suspending thread, resuming thread 1. Okay, so same way we will do for thread 2 also. Object2 dot t dot suspend, suspending thread 2, object2 dot t dot resume, resuming thread 2. Okay, main thread interrupted. After this try catch, one more try catch is still remaining. Wait for other threads to finish. Other means other than main. Another than main thread, and then to finish. After that try object1 dot t dot join and object2 dot t dot join. After this catching the exception over here also, interrupted exception. Again main thread interrupted message I have to print. I can print it with message also plus E, so it will give me the complete description of the object, exception object. Okay, then after this all is done, main thread will be exited. Main thread exiting. I will run this now. So this is my output. First of all, new thread is created. 1. Group priority is 5. Norm priority. Main group of thread. Main group of thread. Then 1 to consume. After this, thread 1 is stopped or suspended to and tell to sleep. Then 2 is only running. 10, 9, 8, 7, 6. Now thread 1 is resumed again. Again they will work simultaneously. 10, 9, 8, 7, 6. And 2 is already come to 6. So it will come from 5, 4, 3, 2, 1. Then suspending thread 2. After this only 1 will run. 5, 4, 3, 2, 1. And then resuming thread 2. After resume, 1, 2 is already finished its execution from 15 to 1. So first of all 2 will be exiting and 1, then afterwards 1 will be exiting and then main thread will be exiting. So this way we were using suspend resume thread before Java 2. So now we will see the newer version to handle this type of approach to suspend and resume thread without using suspend, resume and stop. Why? Because if we are using critical data structures like linked list or stack or queue, in this if we are having some critical files that are very much confidential, very much important, and in between if that thread is suspended, all other threads will be waiting for it forever and that file will be in corrupted state. So for that purpose we are not using nowadays. We must not use this all suspend and resume. It is very convenient to use it, but still we cannot use it. Okay. suspend, resume, demo, to after Java 2. New package SR demo after Java 2. Previous. Again, we will have the same name to class as we were having in theory part. Suspend and resume. Same name with public static void main. Implements runnable. Now, same as previous, string name, name of the thread, then thread T, and one boolean suspend flag. This method is not convenient, but still we cannot use it. We cannot use the previous method. New thread is deprecated. Suspend, resume, and stop are deprecated after Java 2. So we cannot use it. String thread name. Name is equal to thread name. Then T is equal to new thread. This dot, this comma, name. Print the new thread. New thread. Then T dot suspend flag is equal to false. Initialize to false always. Then start the thread. Then entry point, run method, it's very important. Run method is implementation of run is important, as well as starting the thread is also important. Now in this run method, same way we are using for int I is equal to 15, I greater than 0, I minus minus. Okay, so name plus colon plus I. Thread dot snip for 200 milliseconds. Then synchronized. This thread is synchronized. While suspend flag is true, wait. Suspend flag is true means thread is suspended. So thread has to wait unless and until it is told to wake up and do its task. So it has to wait. After this, catch thread interrupted, name is interrupted. Then interruption, after interruption, thread is exiting. Name plus exiting. Afterwards, void my suspect. Void my suspect. Suspend flag is true. So this means that thread is suspended. And synchronize void resume. In this, suspend flag is false. Notify. Then main class suspend resume. Two objects are created here also. New thread object 1 is equal to new thread 1. Then object 2 is equal to new thread 2. After that, try. Thread dot sleep 1000 milliseconds. Then my suspend method object 1 dot my suspend. This out. Suspending thread 1. Suspending thread 1. Thread dot sleep 1000 milliseconds. Then object 1 dot my resume. And resuming thread 1. Same way for second thread object 2 suspending thread 2 and the object 2 resuming thread 2. Catch interrupted exception. Main thread interrupted. Main thread interrupted. Then try catch again object 1 dot t dot join object 2 dot t dot join. Catch interrupted exception. Main thread interrupted again. Then main thread exiting afterward. Output is same as the previous section, but only difference is that we are implemented our own implementation of suspend and resume instead of by default methods, okay, using the flag. So 1 and 2 are created, 1 and 2 running simultaneously. After that, after 1 second, thread 1 is suspended, 2 will be running, okay. Why 5 values are coming? Because in between sleep is 200 milliseconds. Sorry, 200 milliseconds, that is uh, fifth part of 1 second, okay. So 5 times it is running, then thread 1 is suspended, only 2 will be running, then 1 will be again resumed, so both will be running simultaneously 5 times, then thread 2 will be resumed, thread 2 will be suspended, 1 will be only running, after that 2 running, resuming thread 2, after that 1 exiting and main thread exiting. So same output we are getting over here also, but the deprecated methods are eliminated and suspend flag is used. So this way we have completed all the multi-threading examples, practical parts. From the next session, we will be moving to the next topic and we'll understand it like this only. So meet you in the next session. Thank you so much.